We are going to talk about SQL views and their query performance. A SQL view is based on a SQL query. The query is run and the view is created at runtime when we use the view. This may cause performance issues in a large and busy environment. If possible, we can turn a regular SQL view into an index view or a materialized view. By doing this, the database management system will treat the view like a physical table. In other words, the data presented by the view will always be pre-calculated and available for use. This will greatly improve the query performance of a view. There is a very important technical requirement if we want to turn a regular SQL view into an index view or a materialized view. It is the view must be deterministic. Let's talk more about SQL views and their query performance next. Keep in mind, if we turn a regular SQL view into an index view or a materialized view, it will greatly improve the query performance of the view because the database management system will treat the view like a physical table. There are several technical requirements we need to keep in mind if we want to turn a regular SQL view into an index view or a materialized view. The base tables of a view must use the two-part format. In other words, we have to specify the schema a base table is located in. The materialized view or the index view and their base tables must exist in the same database. We cannot have a base table reference itself. In other words, we cannot do a self-join. An index view or a materialized view is updatable. If we just want to update the data stored in a single base table, we can use the regular update command. If we want to update data stored in several base tables, we will need to develop an instead of trigger. This could be important for some use cases. If we update data stored in base tables, it will not fire the trigger integrated with an index view or a materialized view. Let's look at one example. Here, we are creating a regular SQL view first. If we intend to turn the regular SQL view into an index view or a materialized view, we have to use schema binding. Schema binding simply means if we want to change the table definitions of base tables, we must drop the view first. This will make the view more dependable. Once we have created the regular SQL view, we need to create a unique clustered index to turn the regular SQL view into an index view or a materialized view. In our example here, our unique clustered index is based on two columns, customer ID and appointment ID. If we have business requirements requiring additional indexes, we can create non-clustered indexes after we have created a unique clustered index. The rules for determining whether a view is deterministic or not can be complex and tedious, but there is an easy way to find out whether a view is deterministic. We can just run this system function, object property. This function takes two arguments. The first one is the ID of the view. We use this system function, object_id, to look up the ID of the view by the view name. The second argument is to tell SQL what we want to find out. We want to find out whether the view is deterministic or not. If the system function returns 1, then the view is deterministic. If the system function returns 0, then the view is not deterministic. Keep in mind, this is a quick and easy way to find out whether a view is deterministic or not.